So today we'll be talking about DOM manipulations. And how you doing, guys? Okay? Ready for some hardcore? Okay, so what I want you to do before we start, I want you to go to that link, because since it's a workshop, we'll be doing some practical tasks. And I want you to go there. It is a GitHub repository. And so go through the standard workflow, git clone, npm install, and npm start. So I just want to make sure that everyone has access and the application has started correctly. So we're going to wait for a few minutes while you do that. Actually, here's the link. I'm sorry, so you don't type this long link. How's it going so far? Right? Any problems? Okay. Cool. So while you're doing that, I'll tell you a little bit about myself. I am mostly known for Angular in-depth publication that I started with the goal to explain how things work under the hood in Angular. So incidentally, just a few days ago, we reached our first 1 million views. And if you want to become an expert in Angular, I definitely recommend that you check it out, because there are lots of good articles there that go deep into the framework. So if you want to know the internals, this is the place to go. And the way we'll be working today is I have tasks and solutions. So I mark them with tags. So if you want to check out a task, you do just git checkout tags, and then T1, for example, that's for task 1. I'll show you here. You will have the tag name, right? So you check out before we start working on a task, and then I'm going to give you 5 to 10 minutes to complete it. And once we're done, you can check out the solution, right? In the same way here. It will be like solution 1A, right? And if you've done it yourself, you can then compare the solutions. But anyway, I will show the solution on the screen so you can see what's the proper way to do it. And as we go, I think it's a good thing if you ask questions, okay? So here, you should ask questions. I expect you to do that. So has everyone finished installing and running an application? Can we start? Yep, URL, okay. Here. Okay, so I'm going to wait another minute and then we'll start. I will also be playing music while you're doing the practical exercise. I ran it through other people, and they told me like when they get nervous, music helps them relax. So I'm hoping it will have the same effect for you as well. But if it distracts you, just let me know, and we'll turn it on. OK, so let's get started then. A bit of theory. So all DOM operations, we can split into 2 major categories. Modifying existing DOM element properties, like adding class, setting an attribute, or changing styles. And changing DOM hierarchy, creating new DOM elements, adding them to the DOM, or removing an existing element from the DOM. And in Angular, there are specific tools for each of these type of operations. And we will see them today. And we will start with the tools that Angular provides for us with working with existing element properties. And we'll see the approach that we need to use when doing so. So the first part, modifying DOM element properties. And we're going to have to do the task 1A. So as I showed you, you should go into Git, right, and do git checkout. Okay, checkout tags T1A. Right, it's going to check out the initial data, the setup. I'm going to show it to you here on the screen. Do you guys see the code? Maybe I should do it like this. Okay? Is it better? The guys on the back rows, do you see it? A little bigger like this? Okay. Okay. Now, but when you check out 1A task, you should see the same on your computer, okay? So you don't need to go to look at the big screen. So what we have here, and what is the task? The task is, we have one span element in the DOM, and what we want is, we want to change the font color of the span element. And to do that, we need to simply add the highlight attribute, right? Because we have styles that when any DOM element has highlight attribute, the color is applied to it. So the task here will be to get hold of this span element inside the component and add the attribute to it. Okay, what do we need to know to accomplish this task? There are a few important concepts. So in Angular, how do we get access to DOM elements? We use something called template reference variables and viewChild or viewChildren queries. So here's the example. Here you can see that inside the span DOM element, we mark it with a template reference variable, right? It can have any name. And then I'm using viewChild query here and passing the name of the reference to get a hold of this span element. And what is returned is something called element ref. This is simply an abstraction around native DOM elements. We need it because Angular runs on other platforms other than DOM, like web workers, etc., where there is no native DOM, no native elements. But we need something to work with, and that's why we have element ref here. Okay, and then we can use native element property to get access to this native DOM element. Okay, any questions so far? No? We're good here? Okay, the next question is, when can we use this span? When can we access it so we know that Angular evaluated this query? And we can do that inside after viewInit lifecycle hook. Okay? So how are we going to solve this? Here's the steps that you need to do to accomplish this task. You need to use viewChild query and template reference to get an HTML element, the way I showed you. Probably you will use EL name for the reference. And then we use setAttributeNative method and pass in the attribute name. In our case, it will be highlight, right? And then as a value, we can pass an empty string. Okay, so this is the task. These are the steps. Are we ready to go? Everything's clear, right, what you need to do? Okay, then 5 minutes, and after that, we'll check. We'll see how it goes. So as I told you, I will play the music here. We don't hear it. Oh, it's here. Okay, we'll figure it out with this music later. But you go ahead and proceed with the task. Yep. Yep. music. Also, if you have questions, you can raise your hand. I'll come by and help you with this. It used to work, right? Oh, okay. Thanks. Okay, I'm back. So how's it going? Do we have people who have completed the task? Right? Oh, cool, most of the people, cool. Okay, so let's see the solution now. And for those who haven't completed it yet, And for those who want to check out the solution, we do, as I explained, S1A, right? We're checking out the solution. And that's it. It's here. So as I explained, I marked this span element with a template reference. Then I'm using it for viewChild query here to get a reference to this DOM element. And then inside ng after view init lifecycle hook, it's here, right? I'm using native element property to get access to the native DOM element here, and using set attribute method to simply add this highlight attribute to the DOM element. Okay? And if we run it now, like this, okay. So it should go to localhost 42. Check it here. Okay, not ready yet. Okay, good to go. Right, you see, it says I want to be red. Well, actually, I think the task had green color, but I wanted to switch it to red. So, but the idea, you get the idea, right? Okay, so cool. So this is the way. This is how you get access in Angular to native DOM elements. You use viewChildren or viewChild and template references. However, there is one problem with our solution now. And the problem is that we're mixing together rendering and presentation logic. Right? What is presentation logic? Presentation logic defines how business data should be presented to a user. For example, a set of tasks can be split into two columns, with all tasks in left column and completed task in right column, right? So the presentation logic would define two arrays with different set of tasks. What is rendering logic? The rendering logic actually manipulates the DOM, right? It arranges DOM nodes in a particular order so that we actually can see these tasks. And here, we're working directly with the DOM, so we're using rendering logic. But right now, it's implemented inside the component. And the general recommendation is to put rendering logic into components, presentation logic into components, and rendering logic into directives. Okay? And then we can use data binding mechanism to communicate between components and directives. So what we need to do now, this will be our next task. Here, this is what I explained, the problem. This will be task 1B. And we need to implement a directive that will do exactly the same what we've done inside the component, that will set the attribute on a DOM element. So what do we need to know? Well, if we put this rendering logic into a component, we needed to use viewChildren or viewChild queries and template references to get a hold of the DOM element. If we use a component, we don't need to do that because, directive, sorry. We don't need to do that because we can inject a DOM element that the directive is applied to directly into the directives constructor, right? So we no longer need to use viewChildren or template references. Okay, and this is what I'm showing you, right? It's simply specifying element ref type. And then you will get the DOM element inside the constructor. The second thing is that we need to communicate to the directive what attribute needs to be added, right? And as I said, we can use data binding mechanism for this purpose. So we need to define an input inside the directive, and then here, like this, when we will be referencing our directive in a components template, we can pass in the attribute name. And then inside ng-conf, this is the lifecycle hook where we can get access to all inputs. Like all inputs are evaluated by Angular. So inside this method, we can use element set property to do the same kind of work we did inside a component. Okay, so any questions so far, what I've explained here? Everything's clear, right? Okay, cool. So what will be the steps? The task, if we check it out, let me check out the task here. It will be T1B. Okay. So here you already have a directive. It's here, but it's empty at the moment. Okay. So what do we need to do? We need to add an input parameter to this directive, as I showed you, that will take the attribute name that needs to be added to the DOM element. Then we need to inject an element into the constructor. And then inside the ng-on-init lifecycle hook, we will use the setAttribute method of the native DOM to set the attribute. And this is all that we need to do for the directive. And then we simply need to apply this directive to the spine element. So the task is here to move rendering logic out of a component and put it into directive. Okay, so no questions? Ready to start? Anyone? Who's ready to start here? Okay, cool, because, you know. Right, so let's start. Let's get started again, 5 minutes to complete the task. And I think you can check out task 1B, right? So you can start with the directive scaffolding. Okay? So 5 minutes, let's go. I'm sorry, again, if you have questions, just raise your hand. I'll come by, okay? Or actually, I have a person who helps me. It's my wife, so she can help you as well, okay? So, how many people have completed it? Cool, cool. And so let's see how we need to do this. So again, I'm going to check out tags as solution 1A. Oh, we need 1B. Exactly. Right. So as I explained, here's the directive. This is what we do. We define one input, so it has to come from a component. Then we have a constructor with, and we inject the element that this directive is applied to. And then inside ng-on-init lifecycle hook, we access the native element in the same way we did it in the component, and we call the setAttribute method on it. And we pass in the attribute name that is passed down from the component. So this is the code for the directive. And once we've done that, we simply need to apply this directive to the DOM element, like here. Okay? And that's it. That's all we need to do. So what are the benefits of splitting presentation and rendering logic, right? There are a couple of benefits. The first one is that if we put presentation logic into components, this logic can be reused on platforms other than DOM. For example, NativeScript, right? They have their own implementation of the rendering layer. But the presentation logic can be the same. And if we put rendering logic into directives, again, we can reuse it. We can apply this directive that we just implemented to any components template. And then we'll get code reuse. And the third benefit is that you always know where to look for if you get an error, right? If you suspect that it's something messes up with the DOM, you go into directives. If you think that you have set up an incorrect presentation logic, you go into components. It's easier to reason about. Okay, so there is another problem, however, with our solution here. And the problem is that we're using the native setAttribute method. So we kind of expect that there's got to be DOM element there. But what if we run this code inside the web worker? And as you know, there is no DOM environment inside web workers. So this code will fail, actually. You'll get an error. And in Angular, to work around this problem, we have something called a renderer. And it's here. It is the service that makes changes to existing DOM element properties safe. It's platform independent. It has all the methods that we have on DOM elements, like setAttribute, addClass, etc. So what we need to do, we need to replace the logic that we have just implemented. And instead of calling setAttribute method directly on the native DOM element, we need to call this method on the renderer and then pass in the element ref. Okay? So this will be our next task, task 1C. And what do we need to know? Well, basically, it will be the same as we have done already, right? So you can, for those who haven't completed, can check out solution 1B. This will be a starting point. And we simply additionally inject the renderer service. And it's currently available as renderer2 type. So that's exactly what we specify in the constructor type parameter. And then, as I show here, we call setAttribute method on the renderer. And then we pass in native element as a first parameter. Okay? So these are the simple steps, just 2 steps. One thing to notice is that do not forget that a renderer takes a native element. So here, in our case, this will be this element, right? This is because what we inject into the constructor, this element. And then native element. This is like this, right? This is what we need to pass in. OK, good to go? OK, yeah, have a question? Yeah, just the mic's coming in. Sorry.
How would you apply focus with the renderer 2?
Yeah, that's a good question. And it's interesting that it is always the first question that gets asked because renderer doesn't have set focus method. Well, here, you just need to make sure, first you have to understand which platforms you're going to support, right? If most of the Angular applications run inside the browser, they don't run inside web workers, do not use server rendering or native script. So if it's inside the browser, then you just make sure that you implement a check if native element is not null, right? And if it's not null, so you call set focus on this element. So however, this is the approach that is being used right now. There is no set focus method on the render. OK? Yeah, some clarification? Yeah.
So what would be the best practice of, let's say, I need to set an attribute tab index 0, and then I need to immediately apply focus. What should I do? Should I use renderer 2 to set an attribute and then just grab the element directly and then apply focus?
Well, it's a pretty specific question. Let's do that. Let's go on with this, with the workshop, right? But I'll come by now and answer specific questions for you so that others have something to do. Yeah.
Why in the first case we did set apply on after view init, and on second case on
yeah, on init. Yeah, understand. So the question is, why do we use different lifecycle hooks to apply rendering logic? So when we use component, it was inside ng after view init lifecycle hook. Now inside ng on init. It's because we use different strategies to get access to the DOM element. Inside the component, we used viewChildren query, right, to get access to the DOM element. And viewChildren query is what evaluated inside ng after view init lifecycle hook. So these queries are not available before this hook. And here, with directive, we depend on input bindings, right? Input, which is here as the attribute name. And inputs are evaluated inside ng on init lifecycle hook. So that's why we have this difference here. OK, now, let's do that. So I'm going to give you 5 minutes. I think most of you have already done it. So again, 5 minutes. Let's complete this task, and then we'll move forward. OK? Again, if you have questions, raise your hand. I'll come by. OK, 5 minutes then. question, how many people have completed it? Okay. Okay, cool. So, check the solution, and as you might expect, it will be a little change to the existing implementation. So git checkout. By the way, how many people had problems with npm install? Like the npm didn't work because of slow Wi-Fi? Okay, thanks. Actually, not many. I was expecting a lot more, but cool. So it's the solution 1C, right? So here's the implementation. On top, additionally to the element ref, I'm injecting the renderer here. And here, I'm using this renderer set attribute method of the renderer and pass in the native element that I get from the constructor. Okay, the second parameter is the attribute name and the attribute value, which is an empty string here. Okay, so any questions so far specific to this task? Yep.
So you mentioned that we are using the renderer thing just because to make it cross-platform.
Yeah.
So here we are passing the first parameter as this .element.native element. So what would be this parameter in case of say native?
Null, it will be null. So the question is that we're using renderer, but we're still referencing native element property. And what this property will be if we run it inside the web worker. Inside the web worker, this property will be null. So, however, the code doesn't fail, right? Because we do not call set attribute on the null, right? The renderer itself has some workarounds and implementations that allow you to pass a null, and then it knows what to do. Because all renderers are platform specific. So that's how it works under the hood. Okay, cool. So this is the first part. Let me see where we are. Yep. Yeah, so this is the first part. We have completed it. It's just kind of a warm-up. And I showed you that you need to split presentation and rendering logic. We need to use renderer to make our code cross-platform. Okay, now we get into the hardcore stuff, which is modifying existing DOM structure. And we'll start by I will show you what happens if you change the DOM elements directly and do not use tools provided by the framework. Okay? So here's the task. This will be task 2. Yep, it's here. Okay. So let me check out and show you the data. So what we have here, we have one component. I'm going to expand it here. We have app component, and we have a child A component inside, which is DOM element, right? What we need to do is we have a button here, and when the button is clicked inside the remove method, we need to remove this A component from the DOM. Kind of the way you do it with jQuery, right? You just remove the DOM element from the DOM. And how we can do that, right? I'm using viewChildren query and template reference here. We learned about them in the first task to get access to this A component, to the DOM element. And then, so what is the type of viewChildren here? The type is query list. It means that child components variable will contain reference to all elements marked with the template reference C. However, since there is only one element inside the DOM, in the template, we can use the first property of the query list to get access to this A component child DOM element. Okay, so what you will need to do here, you will need to do child components, right? It will be this child components first, right? This will give you access to the element ref specific to the A component. that corresponds to this A component. And then we know that to get access to the native element, we need to use native element. Okay? So far, so good. So what I've just explained. Cool. So this is how we will get access to the host, to the child element here. Another thing is that if we take a look at the remove child element here, remove child method of the renderer, we will be using renderer here. So we need to inject it like this. It will have, and you already know how to do that, right? Just done it. So the renderer has a remove child method, right? Like this. Remove child, yes. And if we inspect the signature for the method, it takes two nodes, the parent node and the child node. Make sense? So we already know, oh. Sorry, yeah. We already know how to get access to this child element. So this will be the second node. So what we will pass inside the remove child, we need a host, parent node, and child node, right? This is the signature. Instead of child node, we will pass this child comps, right? What we've just learned, and first, and native element. So child comps, as explained, is evaluated as a viewChildren query. It has first, the first property that references this A component, and then native element property to get access to the native DOM element. How do we get this parent node? Right. What is the parent node of this A component? Does anyone know? Yeah, it's the host element of the current component, exactly. And it turns out that in a similar way to the directive, we can inject the host element of a component into the constructor. Okay? So what we will do is, on top of the renderer, we will also inject host component, host element, right, like this. And then we can pass it as a parent node. Again, don't forget native element. And this code here will go inside the remove method. So once the button is clicked, this code is executed, and the child component is removed from the DOM. Okay, now let's get back to the steps. So we use viewChildren query and template reference to get an HTML element. And we already have it here. Let me revert it back. Everything, yeah, this is the setup. So we already have it in place. Then we need to inject element ref and renderer into the constructor. I showed you how to do that. And then inside the remove method, we simply call remove child method and pass in a host element and a child DOM node. And again, remember to use native element property on the host element and what's evaluated by viewChildren query. Okay, now I'm going to give you 5 minutes to do this again. The setup is T2. It's the task 2. So git checkout T2. Let me show you here. Right, T2. That will be the name of the tag. Okay, ready to go. Everything's clear. Yep.
Why do you use viewChildren instead of viewChild? There's just one.
Yeah, the question is, yeah, I'm going to repeat it. Why do we use viewChildren here instead of the viewChild? It's a good question. I would use normally viewChild here if I know that I only need one element. But right now, I also have this interesting check implemented. I want to know how many child components are there, right? That's why I used viewChildren to get the length property. But it's specific to this task. So you're right, it would be viewChild otherwise. Okay?
So it's not there because you are removing the child, but just so you can check the length.
Yeah, so I can check the length of all child components. Exactly, correct. Yep. Okay, let's go, 5 minutes. Again, any questions, raise your hand. Okay, bye. So how many people have completed it? Cool, cool. Most of the people do it. That's great. Again, let's take a look at the solution. Yeah, so as I explained, we inject the host element into the constructor and the renderer. Then what we do is, inside the remove method, we call the remove child method of the renderer. We pass in the host element as the first parameter. This will be the parent element for the knob being deleted. And then we pass the native element, the child component's DOM element, to be removed. And that's it. That's the implementation. So if I run it now, here, and click this button, the component is removed. Okay? Now, I'm about to show you a very surprising thing now. So if we explore the DOM here, right, this is our, let me try to make it, okay. Yeah, this is the app root, right, our parent component. And there is only button inside of it, right? No child component. However, if we check the console log, and let me actually rerun it, so I clear the console before I remove the element. Yeah, so I'm going to remove it now. So you see, the number of child components is 1. And what's worse is that change detection has been executed for both A and B components. But if we check the DOM, they're not here. So where are they? And so what's the magic? Is it surprising how many people expected the component's length to be 1? Okay, a few, okay. Right, so why do we get this result? And the reason is because Angular does not work with DOM directly. It has a concept known as the view. This is the data structure that is created for every component, and it holds references to the native DOM element found in a component's template. So this is the diagram that illustrates this. You can see the view on the left and the button element on the right in the DOM. And you see it references it inside the view. And the problem is that if we work directly with the DOM and remove the button element from the DOM, the button view node that sits inside the view is not affected, right? So I've created like this. You see? Moves. Right, so we removed it from the DOM, but it's still inside the view, and the reference is retained. And that's the problem. So Angular still thinks that there is a hierarchy of views. There is a parent app component, inside of it a component, and inside of it B component. Okay, now if you're interested to know more about the view, this is how it looks under the hood. So on the left, I have a component with one button element in a template. So when Angular creates and instantiates a component, it creates the view for this component. And the view is simply an abstraction that binds together component class, instance of a component class, and the DOM nodes, HTML DOM nodes created for this component. And I'm showing you guys here these two important parts of the view. Okay. Now, but we still have, this is for one component, but what if we have child components, right? Then we get a hierarchy of views. So here, for our component, right? So I have one button HTML element and a component element, right? Because every component still has DOM representation, which we call host element. But what's interesting is that it references another view, right? As I said, for every component, Angular creates the view. So here we have app component view that has a reference to the child components view. And change detection runs on this hierarchy of these views. And every single lifecycle hook or view children query also runs on the hierarchy view. Yep. So this is, again, the code for you to inspect. If we have a child component inside, then here, inside the nodes, we will have render element, which is a reference to the DOM element created for the child component. And here, we have the reference to the components view. Okay? Now, I want you to show this view hierarchy inside the console. And actually, what I will do now is I'll go inside the sources. And this is the function that is executed when every single component is being checked. And as I told you, Angular runs change detection on the views, right? That's why the parameter name here is view. So what we'll do now is I'm going to reload, put a breakpoint here, then click remove child element, right? And you see the first view that comes here will be our app component view, right? As I explained, it has a reference to the component class instance and the nodes. Again, as I showed you, if we go through these nodes, there are different types of these nodes. We will not go inside. I don't think we need to go there. But the important part is that once we continue with change detection, the next view we will get is a components view, right? What's important is that you do not see these components in DOM, right? They are not here. We have removed them. But Angular still runs change detection on child components. And if I continue, it will be B component view, right? Okay, so the question can be, what type of nodes can we delete, right? Like jQuery plugin, right? Is it not safe to remove every single DOM node? The general rule is that if you created that DOM node, you can delete it, right? If jQuery plugin adds some DOM nodes, then it can remove them safely because Angular does not know anything about these DOM nodes, right? So there will be no harm done. However, if the nodes created by Angular, it is not safe to delete them without using the tools provided by the framework. And there is a tool that Angular provides for us to work directly with the hierarchy of views. And the tool is, who knows what the name is? It's a view container, right? The view container. That is the tool that we need to use if we want to work with the views. Okay, so let's get back to this view container. What is it? Well, if you imagine DOM nodes, right, then one of these DOM nodes can act as a container for other views. So here you can see that the second DOM node, or view node, acts as a container for other views. So we can effectively put as many views as we like inside this container. And this container implements methods that allow us to manipulate these views, to create them, add them to the view container, or remove them from a view container. And even in some advanced use cases, you can have two view containers and move a view between containers. This is sort of a drag and drop scenario. Okay, so right now we'll take a closer look at this view container API, how to work with it. Just want to make sure that you guys understood what I've just said. So everything's clear here because it's important to understand why the view container is there, not just what's the API. Okay, cool. I'm going to take it as yes, right? Okay. Yep. Maybe can you repeat it?
So is the reason that the view container is there is because that's what enables Angular to keep track of change detection? It doesn't actually track state in DOM nodes, but it tracks it in the view containers?
Well, it's there because it holds other views. Like, you have to have a place to add other views, right? Child components, or as we will see now, embedded views created using template ref. So it's a container, you know, you have to put something there. But yes, it also helps with change detection, right? Because Angular knows that this container holds some views, and I need to run change detection on these views as well. Right? So yeah, it sort of helps with change detection, but the main purpose is to hold other views and to provide an API for you to manipulate these views. Okay, so as I said, it has API to create, destroy, and manipulate the views. Well, this statement here makes DOM hierarchy changes safe. It's actually what is its purpose, right? As you might expect, there is something called structural directives in Angular, right? Like ng-if, ng-for, ng-switch. All these directives are based on the view containers, because there is no other way in Angular to work with the views. And I didn't say that about renderer, but the ng-style and ng-class directives also use renderer under the hood to make these directives platform independent, okay? So what I'm explaining you here is what is used internally by Angular as well. So how do we work with the view container? There are a few things we need to do. First, we need to define the node that will act as a view container. It can be any DOM node in a components template, but usually ng-container is used to be a view container, right? Do not confuse them. This is just the HTML element, and it is Angular specific, that can act as a view container, okay? And to turn this node into a view container, we need to use viewChild query or viewChildren query. But the important part is we need to pass this read view container ref type. That's the important part. That's what actually turns a DOM node or view node into a view container. Okay? So here, I'm using template reference VC here, so I can put it here, or I can replace it here, right? They have to match. But this first part is simply to get access to the DOM node, right? We used it in our first task. However, this part is very important. This is what turns a DOM node into a view container. Okay, and then inside this, I'll call it view container variable, we will have a reference to the view container. And then we can use its API to create views or destroy views or move the views, anything, right? And here I'm showing you the first method that is used to create the view, which is called create embedded view. There are two types of views in Angular, embedded views and host views. We will probably, I'm not sure if we will have time to talk about host views, but they are less important. People do not usually come across them. Usually we work with embedded views that are created using templates, right? So here, I'm passing template ref inside the create embedded view method to create the view and add it to the view container. So actually, this line does two steps. Creates the view and adds it to the view container. Okay, so we know how to create a view container. Then we know how to create the view using the container, right? These are two steps. The last thing is how to get access to a template, right? Because we need a template to pass it inside the create embedded view method to create the view. And it's easy because we have ng-template tag in Angular that we can wrap all DOM nodes that we want to be part of a template. And then we can use viewChild query to get access to this template. And it will return us the template ref type. Okay? I've shown you here 2 ways to do that. The first one is you pass a read template ref variable. So it's similar to how you pass view container ref. You see, Angular sees a DOM node, but it doesn't know what you want from it, right? And you pass this read parameter, and you say to Angular, I want it to be a view container, or I want it to be a template. And the other way is to simply pass the template ref, but this method is less used, so I recommend stick to the first one. Okay, so we know how to get the view container, how to create the view, and how to get a template. So what we need to do now, this will be our next task, which is task 3, right? Here are the steps, and let me check it out first. Here. Ah, okay, it says that I got changes. Okay. So this is exactly the same setup we had when we implemented the task of removing a DOM element, right? What we need to do is first add a view container, right? And we know that we can do that by going to ng-container, right? Then marking it in some way, and then use viewchildren of viewchild. In our case, viewchild will work to get access to this ng-container. Okay? So this will be the first step. I have it here, right? The second task will be to wrap this DOM node in a template. Again, we can do that using ng-template. All right, mark it with template references. Okay, and wrap our DOM node, which is component, but it could have been anything else, right, like this. And then, again, use viewchild to get access to this template. So we will have 2 viewchild queries, one for view container, the other one for template. Okay, and once we do that, we need to do 2 things. First, we need to create the view and add it to the view container, right? Once you do that, I want you to check that you can actually see this component inside the DOM. And where do we add? Where do we add? Where we call create embedded view method. Because since we need viewChildren, viewChild queries being evaluated, we can do that inside ng after viewInit lifecycle hook. That's where we will create an embedded view. And then inside the remove method, since we will have the view container, right, we'll have access to it, we can call clear method or remove method to remove the view from the view container. Okay, so here's the steps. I want you to go through them now and ask a question if there's something that is not clear. Okay? Ready to go? Cool. So again, I'm going to give you 10 minutes for this because there's more work here. Again, if you do not know how to proceed, just raise your hand, I'll come by. And because it's important that you understand it, it's an important topic. Okay, 10 minutes, let's go. So I'm saying that there's significantly less people implemented it, but it's okay as long as you understand the concept of a view container. Why it's there, that it has the API that you should use. And there are two good questions. The first question was, why does renderer have this remove child method that we used? Why does it have DOM hierarchy changes methods? And it's, at the moment, it's purely internal part. So Angular itself uses renderer to create DOM nodes and change DOM hierarchy. It uses renderer because, as I told you, it needs to be cross-platform. But we cannot use these methods of the renderer because, as I showed you, it can have severe consequences. The second question, so again, we use some methods of the renderer to change existing DOM element properties, and we do not use methods that change DOM hierarchy. To change DOM hierarchy, we used another tool, which is view container that we're working with right now. Okay? Now, the second question was, we implemented rendering logic inside the directive in one of our first tasks. Why are we not using it? Why are we not implementing this type of logic into directive now? Why are we implementing it inside a component? And it's just for the educational purposes. So I didn't want to complicate this stuff by bringing in a directive, right? So, but you should always try to put rendering logic into directives, even in this case. If you do that, you will see that what you will do will be quite similar to what ng-if or ng-for does, okay? So let's see the solution to this task. I'm going to bring it here. Okay, I'm going to reset everything and get back the solution for. Okay. Right, so, oh, it's not it. Sorry, this is solution 3, I guess. Yep. So, we had this A component inside a template, right? And the task was to wrap it inside ng template. That's what we did, right? This is the first part. The second part is to introduce the view container into the DOM. And exactly as I showed you, I'm using ng-container here. And I'm using viewChild query to get access to this view container. And I'm also using viewChild query to get access to the template created in the DOM here. Okay, so these are two parts that we need to create the view container and template. So inside the ng after view init lifecycle hook, I'm using create embedded view method and passing the template ref that I get from viewChild query. Okay? Now, when I click the remove button, I'm using the remove method of the view container to remove that view from the container. Okay? And that's the implementation, right? Exactly as I outlined in the steps. So if we run it now, and again, I remove it using the same button, you see we get number of child elements 0 instead of 1. Yep. You got 1? Yeah, it's a good question. Actually, the difference is that, well, we have, I remove and clear. Clear removes everything, right? Every single view in the container. And remove method removes the view that you specify using the index as a parameter. So actually, remove method takes index. Yeah, but since we didn't pass an index, it will remove the last embedded view. And we have only one view, so it will remove it. Yep, there are questions there. Maybe microphone, thank you. Okay. So you're asking what happens if we have more than one ng template? So just we need some clarification. So I can have as many ng templates as I want here. Okay. This can. And you want to do what? Well, you're not, that's an important thing to understand. You're not working with templates. You're working with views. So templates is just the data for the view, right? So here I have two templates. So since I'm using viewChild template ref, well, this could have been rewritten to something like template 1 and template 2, right? Okay. Then using viewChild, I can pass exactly the template that I want here, which will be T1, for example. And this will have reference to this template. Okay, okay, cool. But what I wanted to note is that the view container creates views, and you can call the same method like this. You can call it many times. Even passing the same template, it will create 3 views, right? Because you pass in the template and call this method 3 times. It will create 3 views, but they will have the same input data, right? Because we use the same template. And you will have 3 child components inside. Yep.
Hey, so can ng template contain ng content, like transcluded?
That's a tricky one. So, well, I need to think about it, and I just don't want to take time now. After the workshop, you can come in and we'll explore this use case. Whoever's interested can come by as well. Okay? So,
Yeah, I think you said it didn't matter, but in the example, you got ng container as the tag you're using for the view container. Is there something magical about ng container?
yes. Right, right. The question is, why do we use ng container, right? If we can use any else. Yeah, it's because ng container is rendered as a comment inside the DOM. So by Angular, we render it as a comment. And hence, we do not introduce extra DOM nodes. You know, if we use div, for example, there would be one redundant div in HTML. But ng container is rendered as a comment, so it's not there. It doesn't bloat. Yep. OK. So, yeah. So I think we have time for one task more, and I want to get to it because it's important. Let's get back to, and it's dynamic components rendering. So we have a task here, task 4. Let me check it out. It's going to reset task 4. Okay, right. So what's the data here? So we have 2 components, A component and B component. We have 2 buttons. When clicked, each of the buttons should add corresponding component to the DOM. So we do not know which component to render beforehand. And I have this show method here that depends on the parameter passed to it, decides which component to add, either A or B component. Okay, that's the initial setup. Sometimes people ask, why do we need dynamic components? In this case demonstrates it, right? We do not know which component to render. And here I only have 2 components, but you can have hundreds of components, right, from which you can choose. So you cannot put them, well, the other thing that I saw is that people add them to the HTML inside ng-if, right? So every single component wrapped inside ng-if, and then they control it using the state of a component, which is one solution, but if you have 1 or 2 or 3 components. But if you have hundreds, you cannot add this bunch of ng-ifs there. So in this case, you need to work with dynamic components. So let's get back to our view container. And as I told you, it can hold 2 types of views. The first type of view, which is embedded view, right? And we already worked with it. This view is created using a template. The word embedded means that this view should always be part of a view container, okay? Embedded views are always part of view containers. However, we have another type of views, which is a host view. And the host view can also be part of a view container, but it can also be standalone. So if you think about it, the app component, the root component, is dynamic component, and it is a host view. And it's attached directly to the DOM. It's not part of a view container, okay? So that's the difference between host and embedded views. And when you work with dynamic components and use different API provided by the view container, which is create component instead of create embedded view, the view container creates host views. And the input data for host views is different. What is the input data for embedded views? Like a template, right? I was worried no one would ask. And so for the host views, the input data is component factory, right? So just a quick run over here. So we have metadata. This is what we defined with a component decorator, right? We provide a template for the component. Then there is the thing called Angular compiler that turns this template into view factory. Or it's sometimes referred to as component factory. And that view factory is what is used as an input data for the view. And we've already got familiar with the view, right? We're working with it now. So the view factory is something that is used to create the view. So I'm going to skip it to here. How do we get this view factory, right? We use something called component factory resolver. This is the service provided by Angular that we can use to get a factory generated by compiler for a particular component. So in our case, when we have component A, component B, how many factories do we need? Right, we need two factories. One factory for the A component and one factory for the B component, okay? So we can inject this resolver into the constructor, okay? And then use its resolve component factory method and pass in a component class. In our case, it would be either A or B component. And we will get a factory as a return value. Once you have a factory, it's here, right? So once we have a factory, we can call the create method on the view container and pass in this factory. And it will be quite similar to what we did with a template, right? It will create the view and add it to the view container. So one important thing is to add the components you want to get factories for into the entry components array. And that's because Angular compiler, because it tries to optimize things, does not generate factories for components it doesn't find inside templates, right? And in our case, inside the template, we do not have A component or B component, but we still need factories for them. So, important part, we need to add both A and B components to the entry components so that the compiler generates factories for them, and then we can resolve them using component factory resolver. Okay? So, how do we solve this task? These are the steps. And since we're running out of time, I'm going to show you the implementation. And then you can try to do it yourself after the workshop. So first, we need to add all components that we want to add dynamically to the entry components. Then, similar to the way we did with the view container for the template, to work with dynamic components, we also need a view container. So we need to add it to the template and initialize it using the read view container ref parameter. Okay? Now we need to inject component factory resolver to be able to resolve factories for the components. And once we have a container and a factory, we can use the create component method, pass in a component factory, and it will create for us a component and add it to the DOM. Okay? So actually, I'm thinking that maybe I'm going to give you 3 minutes because I want you to get into it. So just try to understand what is required. Okay, 3 minutes, and after that, I'll show you the implementation. Okay, so you can think a little on your own. Okay, let's go then, 3 minutes. The task that you need to check out is T4. Again, any questions, raise your hand. I'll come back. Okay? Now, how many people have completed it? Oh, cool. More than previous time. Okay, so let's see the solution, which is here. Now, we introduce view container. again. Then we query it here using read view container ref parameter. Then we inject the resolver into the constructor, because we will be using it here to get access to the relevant component factory or view factory. So once I have a factory here, I'm clearing every view inside the view container because I don't want them to nest, like go one after the other. And then I call the create component method and pass in the factory. And that's it, right? That's how you work with dynamic components. So if we run it, just to make sure that it works, yep, show A component, show B component, show A, B, etc. Okay, do you have any questions looking at this code, or questions related to view container, or the type of nodes or views? Okay, no questions. Right. Also, what I would like to mention is that this implementation can be optimized as well. Because right now, when we click on the button, we call each time the create component method, which creates the view again and again. Destroys, creates, destroys, creates. Actually, we can preserve the view that is created by the view container, store it somewhere, and then when needed, we can use different methods, different API of the view container, like insert, right? And we can pass the view directly. And this pattern can be done both for dynamic components and for templates, actually. The methods create embedded view and create component return a reference to these views, right? The create embedded view returns a reference to the embedded view. Create component returns a reference to the host view, okay? And then we can manipulate it, okay? Now, again, where can you read about it, right? Angular in depth, again, this is the place here that I mentioned in the beginning, right? So this is where I and other people who write for Angular in depth explore contents, explore internals, and write about this stuff. And actually, there's going to be an article. I will write an article because we were supposed to do like another 2 tasks, optimization tasks, but we haven't had time. So I'll write an article, and I'll put these optimization techniques in the article so you will be able to check it there. Okay, so thank you for your attendance. Yep. And good luck.